Since we already covered a lot of Chapter 9, Lesson 1 today in class, I'm just going to have you write down some notes about it so that you can refer back to them for studying later and for future problems. So go ahead once I explain this and just hit pause, copy it down, then hit play because there is going to be more after this. What you need to know about quadratic graphs that we talked about today is that there's standard form, and we have f of x or y equals ax squared plus bx plus c, and you just need to remember a, b, and c are the numbers, sorry. So those are the coefficients and the constant. A is always going to be in front of x squared, b is always going to be in front of x, c will always be a constant, a number that doesn't have a variable with it. The graph is called a parabola, in case you forgot that. And remember, whenever you look at A, if it's positive, that will always open up, and it's a U shape. And whenever A is negative, it will always open down if it's a U shape. And then we've got this special point called the vertex. And the vertex is that highest or lowest point, which we discussed is either the maximum or the minimum. Copy that down, and then we'll continue. Okay, so the vertex is your highest or your lowest point, your maximum or your minimum. Remember, when you're asked to graph, you always start at that point. And then to find your vertex, your x-coordinate, you always use that formula we talked about today, the negative b over 2a. And then you take whatever value you find for that, plug it into the original equation or function to find your y, and then you'll end up with a point. So you get x by doing negative b over 2a, plug that in to find y, there's your point. Plot that point, that's where you're going to start. Then you choose two values greater than the x value, two values less than the x value to find more points for your t-chart. Copy this down, hit play when you're ready to continue. There's also something called the axis of symmetry. And that axis of symmetry, if I'm just going to draw a little picture because it's easiest to really look at a picture of this. So go ahead and draw a graph. And I'm going to plot a point that starts at 2, 2 right there, just so it's easy to see. And I'm going to have it go ahead and open down. Okay, if this is your vertex right here, and this was at the point 2, 2, your axis of symmetry is always what splits that perfectly in half. Notice that your axis of symmetry crosses the x-axis at 2, at the point right here for your vertex. Your axis of symmetry is always x equals the x-coordinate of the vertex. Every single time, that's how you'll write it. So the axis of symmetry for this particular parabola would be x equals 2. It's not the y, it's the x. And that's how you write axis of symmetry, and that's how you would draw it in with a dashed line. Draw that, hit play when you're ready to continue. Another thing we're going to look at, and I talked to some classes about it today, but I didn't talk to everyone, is the widths of parabolas. When you're looking at the width of a parabola, how wide it opens or how narrow it opens, the key is from your a again. You look at your absolute value of a because your sign doesn't matter. Remember earlier we talked about the sign of the a tells you if it's going to open up or down, but it doesn't change how wide it's going to open. So you don't even look at the sign, just look at the number, the absolute value of the number that a is. If it's a larger number, it's going to grow faster, so it's going to be a narrower graph. If it's a smaller number, it's going to grow slower, it's going to be a wider graph. And we'll go through some of those, so just make sure you memorize that before your test and understand it as we go through them. Here are a couple hints that you're going to find when you're graphing some of the more basic parabolas. This is the one we talked about today. This one you'll see probably tomorrow. But the hints here are that you're only looking, when you only see like a y equals ax squared, there's no bx, there's no c, your vertex is always 0, 0. And that's what we talked about today. But the other one you're going to come across is when you have an ax squared and a c but no bx. It still makes that first point 0 because when you plug in the no b you get 0. But once you go plug in 0 to your equation that you were given, then you notice you have c left over, so your y is going to end up being c every time on those. Okay, lesson 9.2, which I'm about to go into right now, that's when we start getting the b's included in these quadratics, and that's when finding your vertex gets a little more difficult. Go ahead and write this down, and when you're ready, we'll start lesson 9.2's notes. Hit play. Here's example 1 on lesson 9.2. Because we already have the notes from 9.1, I'm not really going to go into detail on this also since we started it in class. But this is kind of what you should go through in your head as you're solving these. If they ask you to graph and you notice it's a squared, then you know that you're looking at something where you need to graph a parabola. And as soon as you know you need to graph a parabola, you're going to ask yourself first, is it opening up or down, using what we talked about before? What is the vertex? You're going to find the vertex. Once you have the vertex, set up a t-chart for more points. And again, you can go back to 9.1's notes if you need more on that. So let's go ahead and just walk through the example. I think just seeing it is more important than anything so that you have an example later. So first of all, I ask myself if it opens up or down, and I know that it opens down. So that's just going to help me later when I graph it, because if my graph doesn't look like it's opening down, I know I made some mistakes on my t-chart or my vertex. Now I'm going to look for my vertex. Get in the habit of labeling. A equals -3, B equals 6, C equals 5. If you're confused about where I got those from, A is the number in front of x squared, B is the number in front of x, C is a constant, a number that's alone. Notice these are always in standard form. So if these were to move around, I'd have to either put them back in order, or I'd have to be able to look. Whatever had x squared is still my A. Whatever had x is still my B. Whatever was a constant is still my C. Now I'm going to use this formula. So I have -b over 2a equals, -b is 6, so -6 over 2 times a, which is -3. I end up with a -6 over a -6, which equals 1. Now don't get confused and stop there. All that you have right now is the x coordinate. That's all you have is your x coordinate. So you take that x coordinate and you plug that in. So use x equals 1 to find y. And you go plug it into this equation right here. So y equals -3 times 1 squared plus 6 times 1 plus 5. What you're going to find very quickly is that you typically really like these when your x-coordinate becomes an integer, because you'll get fractions here and there's nothing you could do about it. You just have to plug them in. Watch your rules here. It's 1 squared then times -3. So 1 squared times -3 is -3 plus 6 plus 5. -3 plus 6 is 3. 3 plus 5 is 8. Now I have my x and my y, which is 1, 8. So I'm going to write that. Remember at the beginning of the year when I told you you're going to get to problems that are going to take up a whole page? Well, we're here. We're at those problems. So write vertex 1, 8. Pause, hit play when you're ready and caught up. Now that you have your vertex, you want to set up a t-chart to continue. This is where you want to look at your axis of symmetry. My axis of symmetry is at x equals 1. That dashed imaginary line through here. So if I was to go set up, I'm going to go ahead and set up my t-chart right now, or my graph right now, so that you can see it. So what I wanted to show you here as I drew the graph is that if we plot the point for the vertex at 1, 8, here's our starting point. We know it's a maximum because we know that our graph is going to open evenly from there on both sides down because our a was negative. So what I'm going to do is I'm going to write off to the side x equals 1 axis of symmetry. Okay, because oftentimes they'll ask you to label that axis of symmetry. The reason it's x equals 1 is because if I drew x equals 1 as a line on there, if you remember from linear equations, you would start at 1 on the x-axis, you would draw a vertical line for that. This is what's going to split your parabola exactly in half with a mirror on each side of itself. Now from here, you're going to go set up your t-chart. So go ahead and set up your t-chart to find additional values. Remember, go to 1. You're picking points that, and if you think about it, the mirror, what we talked about in class, you know that 2 and 0 are going to have the same answer. 3 and -1 are going to have the same answer. 4 and -2 are going to have the same answer because they're equal distance from that axis of symmetry. So that's what you want to be looking for. So I'm going to pick 2 x values greater than that axis of symmetry, like 2 and 3. And then I'm going to pick 2 values less than like 0 and -1. And then I'm going to go plug them into the original equation. So the original equation was y equals -3x squared plus 6x plus 5. Plug in 2 for x and you'll find the y that goes with that. So y equals -3 times 2 squared plus 6 times 2 plus 5. Don't forget order of operations here. It's a -3 times 4 plus 12 plus 5, which is -12 plus 12 plus 5, so that's equal to 5. And you're going to do that with every one of these numbers. When you plug in 0, because 2 and 0 were equal distances away, you can check your answer because you should also get 5. And notice when we plug in 0, we have 0, 0, 5, so our answer is 5. That's one that we can do mentally. Now we're going to plug in 3. So y equals -3 times 3 squared plus 6 times 3 plus 5. And we get -3 times 9 plus 18 plus 5. And then you end up with a -27 plus 18 plus 5. It's up to you how you want to combine those numbers. Just make sure that you do that correctly. So you can take 18 plus 5, or you can take -27 plus 18. However you're going to do that, just make sure you're doing that correctly. It's easier for me to say 18 plus 5 because then I just have my positives combined. And now I just combine these, -27 and a +23. So there's different ways you can look at that, however, whatever works best for you. And that's a -4. I'm going to move this up. So now I know when I plug in 3, I get -4. And for purposes of time, I'm going to go ahead and just not plug in -1, but typically you would check that answer by plugging in -1 to make sure you also get -4 there. Finish writing that down, plot those points. Once you're done, hit play and make sure you have the same parabola as I do. So your parabola should look something like this. Mine got a little crooked. Sometimes these really narrow parabolas are hard for me to keep really nice and straight. The wider ones seem a little bit easier to draw out. Remember I told you they're going to get more narrow as your A is larger, because we're not looking at the negative, we're just looking at the number 3. If this had been something like 1/4 or 1/2, this parabola would have grown a lot wider and slower as it went down. But because we had a larger number here, the parabola started to grow a lot faster. So you can imagine what can happen when you have really big numbers in the front there. The one other thing I wanted to mention to you, whenever you find when x is 0, hopefully you all remember just from the rest of this year when we've talked about things, when x is 0, you know you're going to fall on your y-intercept. So if they ever ask you to find a y-intercept of one of these, all you do is go plug in 0 for x, you find whatever the y-intercept is. It's the same as linear equations or anything else we've tried to find an intercept for like that. I want to do a quick review on something you learned earlier this year. Hopefully you'll remember it quickly once we go over it. If you don't, you're going to have to ask me more questions about it in class or go review chapter 4, any chapter 4 notes that talk about domain and range. They're also going to be asking you for the domain and the range of these quadratic functions. And you need to remember domain deals with your x values. And if you remember from earlier this year when we talked about these quadratics, your domain is actually any possible x value you're allowed to plug in. And unless we have some type of real life situation where we wouldn't go into the negatives or something like that, your domain is basically always going to be all real numbers. Hopefully you remember that from before. Then your range, so this time it was all real numbers. Your range is going to be based on the limits of the y's. Notice here, all of our y values stop at that vertex, and this is always going to happen. It's always going to be the y value of your vertex. From that value, it's either going to be less than or equal to or greater than or equal to, depending on if that's a minimum or a maximum. So this time it's our maximum, which means everything for the y-axis is less than or equal to 8. And you would write it like this. In this case. So if you need to review that at all, just remind yourself maybe over to the left, go ahead and write yourself a note. Domain, all real numbers, range is either greater than or equal to or less than or equal to the y coordinate, I'm just going to put coordinate like that, of the vertex. And hopefully most of you are getting good enough at reading graphs to be able to figure out that. When it's opening down, they're obviously going to be less than or equal to. When it's opening up, they're going to be greater than or equal to. And it will always be based on that y value of the vertex every time. Write this down. This is example 2. Hopefully you notice instead of an equal sign you have an inequality. Really nice thing about this. If you understand the graphing of the linear inequalities, you're going to apply the exact same rules to this. You're going to graph your boundary parabola, just like we graphed in example 1. If it's or equal to, it's going to be a solid line. If it's not or equal to, dashed line. So stuff we've already learned. And then you're just going to pick a point from either inside or outside of the parabola to plug in and see what happens. And then the shaded side would be the true answers. So I'm just going to walk you through this. I'm not going to write very much on the left because, again, you've learned so much about this and so many of you did so well on your Chapter 6 Part 2 test that I'm not too worried about writing a lot here. I just want you to see one example so we can try them tomorrow. So go ahead and graph your boundary parabola. Make yourself a note, maybe check for dashed or solid. I'm not going to put line because it's not really a line, I guess. It's a U. I'll put a U. And again, to do that, first thing we do is we always look, is it going to open up or down? This one's going to open up because it's positive. And then I start with my vertex. So my vertex is negative b over 2a. Negative b is negative 2 over 2 times 1. Okay, I didn't write a, b, and c down, but I should have. So now I get negative 2 over 2, which is negative 1. Take negative 1 and plug it in. And I get negative 1 squared plus 2 times negative 1 minus 5. Negative 1 squared is 1 minus 2 minus 5. Be careful here. 1 minus 2, negative 1. Negative 1 minus 5, negative 6. So y equals negative 6, which means my vertex is negative 1 comma negative 6. And that's going to be my starting point. Now I set up my t-chart. 2 values greater than negative 1, 2 values less than negative 1. So something like 0 and 1. That's going to be my y-intercept anyway, so it'll be easy. And then negative 2 and negative 3. All right, go back to my original equation. Don't look at it as or equal to or greater than or less than. Just look at it as equal. If I plugged in 0, I know this cancels, I get negative 5. For purposes of time, I'm just going to do this mentally with you, but I always want to see you working them out. 1 squared is 1. 1 plus 2 times 1 is 2. So 1 plus 2 is 3. 3 minus 5 is negative 2. And then again, I could check, because remember, 0 and negative 2 should have the same answer. So when I plug in negative 2, I should get negative 5. So I plug in negative 2 squared, and I get 4. And I'll just go ahead and write it down here. Plug in negative 2, and I get negative 4. And I get negative 5, which equals negative 5. So that one was true. Same thing with the negative 3. Negative 3 squared is 9. Negative 3 times 2 is negative 6. Negative 5 equals 9 minus 6 is is 3. 3 minus 5 is negative 2. Equal distance away from the vertex, so those should have the same answer. Go ahead and plot those points, and because it was or equal to, draw a solid line. Hit play when you're ready. So hopefully you have something that looks like this. Your vertex should be at negative 1, negative 6, and it should have opened pretty even between that axis of symmetry. Remember, axis of symmetry is x equals negative 1 here. Okay? And then our vertex is negative 1, negative 6. Just to review, our domain would be all real numbers because we can plug in anything we want. Our range in this case is all of our y's are going to be greater than or equal to that lowest point at negative 6. So your y's would be greater than or equal to negative 6. Now you need to figure out your shading. So obviously we all know 0, 0 is the easiest point to plug in. If we plug in 0, 0, what we're looking at is all of this, if all this stuff in the middle is true. If we get no, we know everything on the outside is true. And remember, this keeps growing forever. If we get yes, we know everything on the inside is true. So go plug in 0, 0 to the original inequality, which is 0 is less than or equal to 0 squared plus 2 times 0 minus 5. So that's my y, that's my x. 0 is less than or equal to negative 5. And is 0 less than or equal to negative 5? No. So 0, 0 is the no, which means, and I don't have a pencil, so I'm going to just use a highlighter, that the shaded area is not the 0, 0, but it's all of these are possible solutions. And I'm not going to shade above that because that's going to keep growing. So I don't want to fill this area in because then I would be shading solutions that are not true. That's the end of lesson 9.2. We're going to spend a couple days working on this, but make sure you understand how to find a vertex. That's the key to all of this.